All right, let's dive right into one of the absolute biggest mysteries in all of science. We're going to go on a kind of cosmic detective story, hunting for something that makes up a huge chunk of our universe but is completely invisible. We are in pursuit of dark matter.
You know, when you look up at the night sky, it's just this incredible ocean of stars and galaxies. But here's the thing, all that light, everything our telescopes can possibly see, that's just scratching the surface. It feels like the universe is whispering a secret, that the vast majority of what's out there is totally hidden from view. This silent presence that's shaping everything we see.
So, what is the universe actually made of? Well, the answer is pretty mind-blowing. Everything we know, everything we can touch and interact with, stars, planets, you, me, all of it, that makes up a tiny, tiny 5% of the cosmos. Just 5%. The rest is a complete enigma. About 68% is this thing called dark energy, which is pushing the universe apart. And then there's that 27%. And that is our culprit, dark matter. It means 95% of reality is effectively invisible to us.
Now, this 27% we call dark matter, it is truly dark. And I mean, it doesn't give off light, it doesn't block light, it doesn't reflect light. Nothing. The only way we know it's there is because we can feel its gravity. Seriously, you can think of it as the invisible skeleton that's holding our entire universe together.
Okay, so every good detective story has to start somewhere, right? It starts with that first clue, that first moment when someone notices that something just isn't right. And the story of dark matter is exactly the same. It all started with a couple of brilliant scientists who realized the cosmos just wasn't playing by the rules.
So our investigation really kicks off way back in 1933 with an astronomer named Fritz Zwicky. Then it gets this huge boost in the 1970s from the absolutely groundbreaking work of Vera Rubin. These two, they were the ones who really put dark matter on the map.
So picture this, it's 1933, and Fritz Zwicky is looking at this massive swarm of galaxies called the Coma Cluster. He does the math on how much stuff he can see, and then he measures how fast the galaxies are all zipping around. And the numbers just didn't add up. Not even close. These galaxies were moving so incredibly fast, they should have just flown apart millions of years ago. So Zwicky figured there had to be some kind of unseen mass, some extra gravity holding it all together. He called it Dunkel Matter. That's German for, well, dark matter.
Okay, so fast forward a few decades, and another huge clue pops up. Think about our solar system for a second. The planets close to the sun, like Mercury, they whip around really fast. The ones way out, like Neptune, they just kind of crawl along. So what do you think should happen in a giant spinning galaxy? The stars on the very outer edge, they should be moving a lot slower than the stars in the middle. Makes sense, right?
Well, when Vera Rubin actually went and measured this in the 1970s, she found something that made absolutely no sense. The stars on the outside were moving just as fast as the ones on the inside. It was a total shock. The only possible way that could be happening is if the entire galaxy was sitting inside this massive, invisible halo of stuff, providing extra gravitational glue. And that, right there, was some of the strongest evidence yet.
But even then, the case wasn't completely closed. You know, scientists needed a smoking gun. One piece of evidence so clear, so undeniable, that nobody could argue with it. And in 2006, they found it. They found it in a cosmic car crash known as the Bullet Cluster.
Okay, so the Bullet Cluster is basically two whole galaxy clusters that have smashed right through each other. And when they collide, there are really two main things you got to track. First, you've got the normal, visible matter, which is mostly these huge clouds of superheated gas. And second, you've got the dark matter. So the big question is, what happens to each of them during this epic crash?
And here's the absolute kicker. When the clusters collided, the hot gas clouds, the normal matter, smashed into each other and slowed way down, kind of like a cosmic traffic jam. But the dark matter, since it only interacts with gravity, it just sailed right on through. And the result was incredible. The visible matter got left behind, but the bulk of the mass, the actual source of all the gravity, was in a completely different place. For the first time, we were basically seeing the invisible skeleton of the universe, completely separated from its body.
And if that wasn't enough, the evidence doesn't stop there. By studying the oldest light in the entire universe, the afterglow of the Big Bang itself, scientists can measure the ingredients of the baby universe. And guess what? Those measurements confirm it with just stunning precision. About a quarter of the early universe was made of, you guessed it, dark matter.
Okay, so at this point, the evidence is it's overwhelming. There is
definitely something out there. So the next phase of our investigation has to be, what is this invisible culprit? What is it actually made of?
Well, it's often easier to start by figuring out what something isn't. So, like any good detective, let's rule out the usual suspects. We know it's not made of normal atoms, because if it was, it would interact with light. We can cross that off. It can't be common particles like neutrinos. They're just too light, too zippy to clump together and form galaxies. And it's probably not a gazillion black holes, because we're pretty sure we would have spotted their effects by now. So scratch those off the list.
So what's left? Well, this brings us to the prime suspects, a whole zoo of weird theoretical particles. The leading candidate for a long time has been the WIMP. That's for weakly interacting massive particle. It's this heavy, super shy particle that would just barely notice normal matter. Other ideas are things like Axions, which are incredibly light, or even sterile neutrinos. Right now, deep underground in these enormous detectors, scientists are basically just waiting, hoping to catch one of these ghost-like particles as it happens to pass through the Earth.
But hang on a second. What if we're on a total wild goose chase here? There are some scientists who have proposed a pretty radical alternative. What if there is no dark matter at all? What if our fundamental understanding of gravity itself is what's wrong?
These alternate ideas, with the most famous one being called MOND, they basically suggest that gravity just behaves differently on really, really big cosmic scales. The idea is that with just a few small tweaks to the laws of gravity we know and love, you could maybe explain why galaxies spin so fast without needing any extra invisible stuff at all.
Here's the big problem, though. While these theories do a pretty decent job of explaining rotating galaxies, they completely fall apart when you show them something like the bullet cluster. There's just no way for modified gravity to explain why the center of mass is over here, while the visible stuff is way over there. The evidence still points overwhelmingly toward a new type of stuff, not a new theory of gravity.
So, where does that leave us? Well, the hunt continues, really on two major fronts. We're trying to map the huge cosmic structures that dark matter has built, and at the same time, we're still searching for that one tiny particle. And to really get a sense of just how important it is, you have to look at something called the cosmic web. Using supercomputers, we can simulate how, over billions of years, the gravity of dark matter has pulled itself into this gigantic, invisible network of filaments and nodes. And galaxies, like our own Milky Way, they form right at the intersections of this cosmic scaffolding. The bottom line is, without dark matter, the universe as we know it, it just wouldn't exist.
And the future of this hunt is just so incredibly exciting. We've got a whole new generation of super powerful telescopes coming online, things like Euclid and the Rubin Observatory that are going to map this cosmic web in more detail than we've ever seen before. And at the same time, deep underground, even bigger and more sensitive detectors will keep up that patient search for the one elusive particle that could finally solve this mystery.
It's a fascinating way to think about it, isn't it? That dark matter is like the universe's subconscious. We can't see it, we can't talk to it, but we can feel its influence on everything. It's the hidden architecture, the invisible force holding the very fabric of the cosmos together. And trying to understand that unseen world, that's really what makes this whole thing so profound.
And that, of course, leaves us with the ultimate question. We've figured out that there's this vast, invisible part of reality that makes up 5 times more matter than everything we've ever seen or touched in human history. So it really makes you wonder, if we've been missing this much for so long, what else is the universe hiding, right in plain sight?